In this video, we're going to be adding and subtracting decimals. It's not any different than adding and subtracting whole numbers, but you do need to be very careful and pay attention to place value because you can make careless mistakes if you don't know your place value. So the first thing we're going to do is we're going to look at an addition problem. We're going to add 1 and 25/100ths plus 3 and 9/10ths. So the first thing we're going to do is we're going to estimate. We're going to get an estimation for how much this should be about, and then we'll actually do the problem so that we can see that our estimation is close to our actual. When I'm estimating with decimals, I want to try to get rid of all decimals. So I know that 1 and 25/100ths is closest to 1, and I know that 3 and 9/10ths is closest to the whole number 4. When I add those together, I have an estimation of about 5. So when I do my actual problem, my answer should be pretty close. It will be 1 and 25/100ths, and then in this next step, I'm going to make sure that I line up by place value. The decimal is helpful in that it makes sure I line up the decimal, and that will make the other numbers naturally fall into their place value. I am also going to put a 0 at the end of my 3 and 9/10ths as a placeholder. In addition, it doesn't make a huge difference, but it will in subtraction, so we want to make sure that we get into that habit. I want to remind you that you can only put zeros at the end of decimals, otherwise you will change the value of the decimal. You can't just stick a 0 wherever you want to as a placeholder because it will actually mess up your place. I am going to place my decimal right down, lined up, and I'm going to put that down, and then I'm going to add just like normal. It's like I'm adding 125 plus 390. So I get 5/100ths plus 0/100ths is 5. 2/10ths plus 9/10ths is 11. Just like in regular addition, I can only put down the 1 and regroup the tens. So 3 ones plus 1 plus another one that I regrouped is 5. So if you look, my estimation and my actual answer are close together, so I can prove that my answer is reasonable.
Okay, now we're going to do a subtraction problem using 72 and 45/100ths, subtracting 4 and 28/100ths. So I'm going to estimate, just like we did with the addition problem, to get a value, to get a difference that is close to the actual. So when we take 72 and 45/100ths, we would change that. I know that it's closer to 72 because when I look at 45, I'm deciding whether or not that's not a 5, so I need to stay closer to the 72 than I would rounding it up to 73. So then I need to subtract 4 and 28/100ths, so I would round that to 4 because it's closer to 4. And then I cannot subtract 4 from 2, so I need to borrow from my tens. I take that 10 and add it to my 2, becomes a 12. 12 minus 4 is 8, and then 6 minus 0 is 6. Okay, now I'm going to calculate my actual amount. So I take 72 and 45/100ths, and I subtract 4 and 28/100ths, making sure that I have lined up all of my place values. And I'm going to, first step, I'm going to bring down my decimal. So that way it reminds me that I have a break in between my whole numbers and my parts. So I look at the hundreds. I cannot take away 8 from 5. So I borrow from my tenths, and 15 minus 8 is 7. 3 minus 2 is 1. And now I'm moving to my ones and realize that I can't take 4 from 2, so I borrow from my tens, make my number 12 now. 12 minus 4 is 8, and 6 minus 0 is 6. So now I have 68 and 17/100ths. If you can see that number is close to my estimation, and that is why an estimation in subtraction or any mathematical operation will give you an idea of how close your actual